The idea that my students know but don't understand is the phases of the moon. They know that there are 8 moon phases and that the moon revolves around the earth, but they don't really understand why. The normal, traditional way of assessing my students to see if they would know the phases of the moon is to fill in a diagram. However, my more creative, real-world version is a question. Imagine yourself looking into the sky tonight and seeing a waxing crescent. Explain how you are able to see it. My 5 possible answers is the moon's shadow is covering most of the moon, allowing us not to be able to see the part that is in the shadow. 2, the Earth's shadow is covering the moon, making us not able to see it. A very simple answer, waxing means that it's getting bigger. They do say that a lot. And then the other 2 answers are activities that we have done in class. So the first one is a styrofoam ball activity with a flashlight. Based on what the student here can see of the styrofoam ball, that is the amount of the moon you can see. And number 5 is explaining it via the simple moon phases diagram, which we have done in class.
Hello, today I'm going to talk about Newton's first law of motion. So it states that every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. More simply, we refer to it as objects in motion stay in motion, objects at rest stay at rest until an external force is applied. So traditionally, we would ask students to either draw a diagram to tell us that they know this. We would also maybe do a fill-in-the-blank question, such as the blank states that objects in motion stay in motion, etc. Or we might even do a multiple choice question, such as which of the following represents Newton's first law of motion. Now, a question that could engage them creatively would be, imagine a time in life when you have observed Newton's first law of motion in action. Use what you know to help me understand what is happening scientifically. The students could possibly answer, so I used the diagram to show what happened here, and my books on my desk, they stay still because they're at rest. And you see we got the force of gravity acting on it. We've got the force of the table, okay, because that's pushing up on it. But these books, they're at rest because those forces are balanced. So what happens then is when I come with my hands and I push these books, I'm applying an external force, meaning that these books are now going to move. And that's Newton's first law of motion. So I really like to go rollerblading a lot, and when I go rollerblading, I go until I stop. My dad, don't tell him I told you, but he speeds a lot, and I always wear my seatbelt, because if I don't, okay, when my car is going 60 miles an hour, I'm going 60 miles an hour in my car, because I'm in motion just like my car's in motion and I'm in that car. So when I'm going, if my dad applies the brakes, that's an external force. Thus, I stop. When I stop, I only stop because my seatbelt is the external force acting on me. Okay? I'm still in motion. I'm moving until I hit the seatbelt. Thank God for seatbelts, right? So we go sailing, and I know that when we sail and our mast is up, we go at a constant direction. But when the wind changes direction, we change direction. Therefore, the forces are constant. We're in constant motion until that wind changes its direction. Once the wind changes the direction, it applies a new force. And that force, therefore, makes us change our direction of course. So when I go sledding, I love to go sledding, and I noticed when I'm sliding down the hill, and when you bump into people and they push you off your sled, well, what happens is, first of all, gravity's pulling me down, okay? So I'm sledding down the hill, going crazy fast, I really like that part, and my motion is that way.
Well, if another sled is coming down the hill and it hits me from the side, I notice my sled goes out from under me in that direction, and I stop usually because this sled over here is another force being applied to my motion and my sled's motion, and they affect us differently.